Check, check. Ah, there we go. We are back. We are back, but we were never here, so we arrive. Hi, Joseph. Nice to see you. Yeah, thanks so much for letting me know. I think it worked at some point at the beginning of the stream, but yeah, I've been having some peripheral issues on this Windows partition, so oh well. Doing some interesting work. Well, I'm trying. um, what I'm doing is, let me bring up my log. So this stream is a PureScript stream, right? And one of the things that we've been doing, like the big picture of things, is we're playing with a library, or not really a library, actually, a paper called um, that implements this data structure called chronofolds, which are a CRDT for collaborative text editing, and like a modern CRDT that's meant to be more efficient than anything else that's out there. And so we did a basic PureScript implementation of the algorithm without much of the optimizations, just capture some baseline performance. And then I started working on a prototype, and then things sort of like veered in a bit of a slightly different direction because I basically attached a whole bunch of work that I've been thinking about in the past year onto that prototype idea. So it's not so much of a prototype than a kind of a workbench for experimenting with some, I suppose you could say, UI development ideas. And so some of these UI development ideas are this thing that Phil Freeman, the inventor of PureScript, um, came up with, which is PureScript React Explore, which is really one example of this idea that he calls Comonadic UIs. And Comonadic UIs are there is a blog post right here. Common as spaces, and I'll copy that for you. So this has really been a super fruitful sort of thinking pattern for me in terms of um, not just UI development, in fact, but just basically I had been catching up on free monads and how it's a really cool pattern to replace monad stacks because potentially it's more composable. And there's this whole concept here of the fact that you can pair a, a co-free comonad with a free monad, and that this pattern is actually more general than that, that the way that you pair a free monad with co-free monad is very similar to the way that you would pair a state monad with a store comonad, or writer monad with a trace D comonad, or reader monad with an env comonad. And that, in fact, apart from the sort of interesting way that these things pair, there's a deeper correspondence here, which is that you could see React as being an instantiation of that pairing for the state monad and the store comonad. And that Halogen, a very in-use library in the PureScript ecosystem for UI development, is an instance of the free co-free pair. And Elm or Redux is an instance of also a specific free co-free pair. And so that kind of stuff really blows my mind, when you're like, oh yeah, this whole ecosystem of application of, this whole pattern of UI development is actually just an instance of this more general pattern. That's one of the reasons why I love functional programming, and this aha moment of like, oh my God, this actually fits into this broader category. Incredible. Like, like monads even, right? Like monad, like, oh wow, you can put in the same category like imperative coding as well as state management or environment, or getting stuff from an environment. Like, it's crazy that all that stuff fits in the same monad pattern. And so yeah, so I love that stuff. And it just happens that the way that this turns out in practice with free and co-free pairing, I find is very, to me, very clear. And I show you the code so that you can tell me whether you think it's very clear, because I can, I can understand that if it's the first time you hear of all this, it might feel like a bunch of abstract nonsense. But here's what it looks like in practice. In practice, your free monad will be something like this, like counter events. So you define that a counter can have something that changes the current count to an arbitrary integer, and then an increment function that would just increment it. And so you define your DSL by saying my counter will take in change count events and increment events, and that will be the functor that is the basis of your free monad. So you just derive a free monad from the counter events, and that's your actions. And then your co-free comonad is based on another functor at this base, and that's actually an interpreter. And so basically what this means is that this pairing, especially when instantiated to the free co-free pairing, is the mapping of actions and the way they're interpreted. And more than that, in fact, the insight from the Comonada spaces is that, and I'm paraphrasing, and it's just the latest way that I'm thinking about this, is that events and your free monad are really basically like the steering wheel or even the car that you're moving. And so you can act on it by changing a count or incrementing, which could be equivalent to turning left or turning right. And your interpreter defines the space of all the places that your car can go based on the actions that you've defined. And so you can say, well, if you turn left many times, then this is where you're going to end up. Or if you turn right many times, this is where you're going to end up. And so basically this pairing means that you can conceptually pair any sequence of actions taken by your program in that are part of your language of actions with an interpreter that basically defines the spaces or the change in the state space. And so the space in like the equivalent of the country in which you're driving your car, or the roads in which you're driving your car is, and so therefore the spaces really are the state space. And so here our state space is defined by a counter model that's just a record with an integer in a count, in a count field. And so our interpreter really just says, you give me the current count, and based on the action that you've taken, I'll give you the new count. So I give you the new state. So basically the interpreter is the graph of all possible ways in which you can move through your state space. So all the ways in which you can change your count in this simple example. And the ways in which I can change my count is either by incrementing it. So then my count, my state space, then it's kind of like a line. It goes from 0 to the only 1, and then to only 2, then to only 3. There's only one interpretation that can happen if I can only increment. But if I can change count, then there's a branch each time where I can, at each of the branch, I can either increment that will go to the next thing, or I can actually change the count to anything in the state space. So I can actually teleport to any place in the state space if I want to by using change count. And so so that's kind of how I think about these abstractions. And the fact that then if you have free and co-free, then you can just build your apps, like you can build a bigger app by composing all of your free monads and your co-free comonads. All of this composes completely naturally, including the fact that you define the pairing of your free and co-free stuff in this pairing instance. Well, if you just add and multiply all of your composable free and co-free stuff. Let's say you have a counter here, and then you have a car there, and then you have whatever form over here. Then you can compose your car and your form and your counter together. And if you do this with the typical language of composition, then you'll get your pairing for free. So you only have to define your pairing at the bottom for each of the components, and then once you compose everything together, then the pairing is defined once and for all. You don't need to even write it. So that stuff to me is really exciting, and I think it's a yeah, I think it's part of the stuff that already exists in some frameworks like Halogen. But yeah, I'm kind of thinking about this a little bit from first principles, so to speak, to just make sure that I understand it well. And as part of this, I was playing with trying to connect it to some of the stuff that I know and like from the PureScript ecosystem. And one of these things is PureScript React Basic. And then today, I realized that one of the things that I need to think more about is how to do state management. And because now if we have a tree of components that's moving sort of together in a composed state space, we still sort of not dealing with the incremental diffs that React is good for. And so if I want to interact with the React ecosystem in some ways, which will gain me a lot of stuff, like it will gain me, accessing existing components. It will gain me using React Native, meaning that I can have an Electron app, a iOS app, an Android app that are all using the same code base written in PureScript, and maybe even with existing React components. So I'm ready to do quite a lot of thinking to try and continue connecting to the React ecosystem. And so that's kind of what I was thinking about when you arrived, is this fact that I could go down the PureScript road and find other ways to deal with state that are more native to how PureScript does it. But I was sort of looking at how the latest stuff that I came across when I was doing some research on it, on like how React is dealing with smart ways to map a component tree into a data flow state graph. And the more recent stuff that Facebook itself came up with is this library called Recoil, which is kind of using stuff that come quite a bit from the FRP ecosystem, which is data flow programming, but with the ability to map that onto a component tree. And I think that that's probably the right top level abstraction, except that it's a bit ugly in JavaScript because JavaScript is ugly. So I was looking at this and just to try and get some inspiration about how I could maybe reuse these patterns so that at least I could be compatible with components that can reuse this pattern, and maybe just also learn about how that would look like you use this pattern. And it just happens that there's also this developer called Oreshinia, who has been playing with exactly those same concepts, but in PureScript. Unfortunately or fortunately, I don't know, but he doesn't use React at all. He just rebuilt a whole UI framework based on the Recoil and React hook sort of design patterns without using React hooks and without using Recoil.js. So I wanted to also look at this because reading PureScript code is always so much more pleasant than you're reading PureScript JavaScript code. But I wanted to just learn a bit about how the JavaScript world is doing it before diving into how the PureScript world is doing it. Nice. Yeah, that's totally how it happened for me in the past 5 years that I've been progressively, dipping my toes and then my feet and then my legs into the more lofty abstractions that come with the functional programming paradigm. Feel free to ask questions. I'm totally happy to help you out with some of the stuff that you're you feel are at the edge of your current understanding. Okay, so right, so this to-do item creator is just a little empty to-do list item, and then when people click add, then it will call the set input value, call the set to-do list function, which is created by this hook, and that takes the old to-do list and returns the new to-do list, which feels quite a lot like our pattern right there with our counter. When I was writing the interpreter, we're basically taking the counter and returning the new count. So, except ours is actually smarter. Like, this is not as smart. Definitely not as smart. Interested in writing interface in purely functional? Yeah. Still in the early day in this space. Yeah. Yeah. So, to some, writing anything but native code is a bit weird, right? But there is a reality where the world has adopted JavaScript as a ubiquitous runtime because it's in the browser and because of things like V8. And so PureScript, obviously, there's a huge amount of overhead that you incur for that, or let's say in a different way, to manage a very different set of concerns to run at higher performance. To need to understand the V8 JIT and how it does its own data and its own performance tuning. And so that's a whole layer that's, most folks that are interested in high performance stuff will definitely not want to go there because there's already, for people who like to be close to the metal, there's already so much compromise that go into using a garbage collected language like Haskell, right? So just dealing with that garbage collection layer is already, for some, it's already a big trade-off, right? And then be willing to go down to C++ to gain some orders of magnitude in performance and link their Haskell to it. But I quite like the whole PureScript ecosystem for several reasons, right? Because it's a more modern Haskell in some ways, right? They've done some design choices like extensible records from the ground up that mean that there's, and the Haskell has still not to this day solved that problem, and it's a bit of a thorn in our side. So the fact that to be using PureScript, it means kind of using maybe what Haskell in some respect will be interface-wise maybe soon, right? You don't get a lot of bells and whistles that Haskell has, but something that you gain is that you can run on V8, so you can run on anything that supports JavaScript, and if you're ready to embrace, which I did quite a bit myself, and that's why I'm thinking about cross-platform in a slightly different way. It's like if you're willing to, to write on top of React, then you can have React Native, and React Native has actually a fairly good cross-platform story, and I've actually shipped React Native apps for work, and sure, it's not going to be as snappy as a Swift app or a Kotlin app or something like that, but still pretty close for a lot of things. And like the React Native ecosystem actually has things like GL bindings, right? You can do 3D with React Native on mobile platforms and in the browser, so you can actually write I have done some experiments with writing OpenGL code that will, use the 3JS library and run in the browser and on mobile platforms in JavaScript. So it's pretty awesome to then think that if you write pure script instead of JavaScript, then you can also have the comfort and the robustness of a functional programming language. But that's a different approach than what we were talking about last time, right? Here, I take another hat, not the hat where I'm going to, you know, um, compile my binary and link to it from Swift in an iOS app, but which would be the kind of the close to the metal, I like speed kind of way, but no more like I write JavaScript, low-level programmers hate me, but I don't care because I can run my stuff everywhere and super fast, and I can have actually pretty cool set of tools and libraries that everybody uses that I can interoperate with pretty easily. So it's a different hat, and I'm trying to play with both because because actually, to be honest, I have more experience with the kind of the JavaScript side of things originally, and I came to be more aware of doing more the low level stuff more later in my career. Yeah. Yeah, Haskell WASM, absolutely. Yeah, actually, there's an effort also for PureScript WASM. And PureScript has also a C backend. All right, excellent. Yeah, yeah. So that WASM to web mobile, WASM to mobile story. I don't know much about. I think that's going to be a whole other ecosystem that's going to develop around that. But right now, I don't know how. It's probably very much in its infancy. Um, but yeah, there's an effort to do PureScript bindings for WASM. PureScript WASM. Well, actually, that's a library. It's not a backend, but there could be a backend at some point because a few PureScript backends. Uh, PureScript backends. PureScript native targeting C++, 11 or Go. Pure Erl for an Erlang backend. The PureScript is more developed than we necessarily think of sometimes for people who don't know it. So it's quite an interesting ecosystem. You could do pure. There is a path to WASM already. You could do PureScript to C++, 11 with the pure native that we were looking at. PureScript native, which is actually pretty well maintained. Yeah, like 2 months ago, so not too bad. And then C++, 11 to mscript_m. So that's a fun way. And yeah, definitely give PureScript a shot. It's nice. I really like it personally. So much easier to build and run things than with Haskell. Okay. Let's see. So I think I get this. Clearly, I don't like the interface, but I get it. Now I want to look at selectors. Selector represents a piece of derived state. Yes, derived state, powerful concept. Filter to-do list statistic. Yeah, so and so it's defined with this constructor that means that it's going to do some smart things about subscribing to the right piece of state and so on. And then when you do have stats and filter, then the filter is going to update filter. Which is maintained in to-do list filter state, right? Which is the selector. So from the selector, we create a setter, a getter, and a setter, basically, and then we use the get option to configure our dropdown, and we update the filter with a callback here that's going to call the set filter. So just the typical JavaScript ceremony here. And then the stats are going to be some bunch of derived stuff. So that's another selector that's defined here. And yeah, it's only a getter, which makes sense. It's a bit like a lens. In the Cycle.js, actually, I think they have a derived lens. And derived state also exists in other React frameworks. And yeah, so it gets the list from the state atom, and then derives a bunch of stuff from that. And so I suppose that it's all about this get function that creates this data flow graph that's going to be updated in a smart way. Even if you have a very complex data flow graph, then if only a small part of it is modified, then it's going to be smart enough to only update the stuff that depends on it downstream. So that's really the whole point of this, and I think that's the correct aha moment for the React ecosystem standpoint, which is that a component tree basically constrains. It makes sense for rendering, but it doesn't make sense to necessarily map your data model to the component tree. There's always going to be some kind of impedance adapter between your data and your component tree, and then the more recent or smart way to manage a bunch of stateful stuff is by being really smart about how you incrementally update. So it's basically really kind of a stream paradigm with then what I like to think of as the kind of the CQRS ES model as well, which is this model where you have the event sourcing model, where basically all your state is just derived from a bunch of events, and then if you get the latest event, then you're what's called a projector or projection in the event sourcing parlance. Then the right projection then just gets updated and incrementally updates just the right piece of state that needs to be updated. So now this stuff is kind of appearing more clearly into UI frameworks in the JavaScript world. Okay, let's look at PureScript Grain now and how they've interpreted this new way of doing things in the React ecosystem into PureScript. So let's first look at the examples. And let's just look at a counter for start. And it's very small, and I love that about functional programming languages. So we attach to the JavaScript world through there. We have a simple counter new type. We derive show instance, a new type instance. Right there. Yeah, I remember there's this local grain concept and then global grain concept. So with the local grain, it's going to be managing local state. And I quite like this because this does definitely make sense. That is definitely the other piece that's missing for impedance adapter between the React ecosystem and state, because it's not just mapping any global incrementally evolving, let's say, streaming data flow graph to a component tree. In fact, some of your component tree is going to have local state. And so you also need to declaratively map which state needs to be maintained by or kept locally in your component tree. And that matters for things like offline apps where you want to persist local state into local storage, and so that when you're offline you can still do things, which I'm I think very important. And yeah, I mean that's the most important stuff. there's other corner use cases in which it's important, but and also there's the case where there's transient state on the component side that you're happy to throw and not to want to store. So local grain, I think, is the case where there's a one-to-one mapping between your state and the component. So you get the value, you have like a hook-like thing where you get the value. Right, so it's different from the the way that JavaScript does it, which is in some sense prettier here, because you can do this, like this new idiom that started appearing with this array deconstruction thing in the hook world. So you get both your filter and your set filter in the same statement, whereas here you have to have two statements. But in PureScript React Basic Hook, you can do it with only one statement too. So it's a pretty thing, like this, using the exact same idiom, but with this tuple-like. It's actually not really the tuple constructor here. It actually is in PureScript, there is a nested tuple constructor that's like this, but I think this is not the nested tuple constructor. I think they define their own thing. Am I right here? Oh, no, it is the nested tuple constructor. Oh, lovely. Oh, I love PureScript. I love functional programming. Okay, so we get a count and an update count, and then we define some helpers for incrementing and decrementing that use the update count thing. Right, so over, I think, is a combinator from the grain thingy. No, it's not. What is over? Oh, it's new type. Oh, I see. It's just yeah, it's basically mapping over when you have a new type instance. That's neat. I mean, I'm sure I would need this all the time. Oh yeah, and this is the pretty Lambda syntax from PureScript, something that Haskell doesn't have. This is equivalent to Lambda x to returning x plus 1. You can write it like this. It's quite pretty and concise. And then then it passes increment and decrement to onClick, which is what you would expect, and it just shows count, which is also what you would expect. And so all of this is gotten sort of for free simply by with this type level trickery there, which is using this L proxy, which is the local grain proxy. Is that right? Yeah. With this fake or this kind of polymorphic type, which say, yeah, my local grain is of type something count, and it knows how to, using subtype level magic, it knows how to use the right how to get the right getter and build the right getter and the right setter. So this is pretty advanced type level programming right there. Especially if you want to build a library that does this. Using this is actually not too hard, but building a library that does this, much harder. And then it's just styles. Wow, because there's just not even CSS outside, so it's super concise, right? Dealing with the simple case there. And you are right, and we get that simply by defining the local grain. Oh, that's so interesting, because this is exactly the interface that we were looking at right here. The initial state and, well, render, not exactly, but initial state. That's pretty much exactly what we're looking at here, and thinking about how to do the mapping between the two. Huh. So what do I learn here? Well, I learned that from someone that thought about the problem a lot, they come up with the idea of defining initial state in a type class instance. It is a bit weird to have data in a type class instance. That's a pattern that I've actually pretty much never seen, but it could be a way to also get over the fact that PureScript doesn't have more advanced type level stuff like I think data families maybe. That would be a way that maybe this would be done in the Haskell world. Maybe that's slightly at the edge of my understanding. But it's pretty cool. It's definitely feasible. And plus it's parametric. So I suppose that the fact that this is a static data type, it can probably be done in a different way here, since this is the simplest example. But I love how the simple example is really simple. That's really nice. Okay, let's look at the global state example now. So global state defines a global grain, and global grain also has initial state, but the initial state actually right now has now date time in it. So that's quite interesting, especially because does this mean that this is going to update dynamically? Okay, well, it's a good idea, especially if, Joseph, if you're still around and you're new to PureScript, then I'm going to showcase how simple it is to get started with it. So I'm going to git clone. I'm maybe not in libraries. So let me create a new shell here. I'll go into shared. I think I have a workshop place here. Yeah, and I'll git clone. I git clone this. And I'll go into PureScript grain. All right. Hey, don't forget to ask me to repeat something. Really, it's just you and me right now. So, and I'm sure that since I'm posting those on YouTube, people will be grateful if you're asking questions as well. So definitely don't hesitate. This is me working in the open, but I also enjoy contributing a bit. Oh, okay, permission denied. That must be because I don't have SSH key configured here. That's all good. So, showing off how easy it is to get started with PureScript. So you do need to have some stuff installed like Git and Node. So that stuff is what it is. It's not the best. Actually, yeah, I think, yeah, no, you do need Node for this. So let's see what's in the package.json here. Oh, yeah. Actually, yeah, Parcel and PureScript. So we need to npm install here to install a bit of tooling. Most of that stuff I actually have in my globally installed, but doesn't hurt to install it here. And so the tooling also for PureScript has improved quite significantly in the past year with the spago command. It became really nice. So now that I have the sort of the node tooling layer, now I can stay in the PureScript world and I can spago install, which will install all the libraries. Yeah, let me open up the code base I just downloaded here. PureScript grain here. Return a fair amount of TypeScript, right? So yeah, npm and node, good. Like a experience with Haskell, as preventing me from diving into PureScript. So you know that I started with PureScript myself before getting into Haskell. So I did find it easier because you can do things like looking at the generated JavaScript code, or and there's plenty of stuff that are kind of JavaScriptisms in some sense because it is for the JavaScript ecosystem. So it meant that it gave me some anchoring to maybe get then slowly into the more advanced concepts. So just a word of tooling here in the spago.dal. Here we have some dependencies that are listed, and in the package.dal we also have package set, which is listed. So there are really not a lot of dependency here, just the web.html. Oh, and I suppose the parent folder. How is the parent folder installed? Oh, well, then we do spago build, which is compile stuff, and that creates an output. They'll create an output folder. Ah, right, I get it. I'm not in the example folder here. Global state here. Right, spago.dal does depend on grain and GS timers, right? Okay. And right, so we have an output folder, and so each library that we depend on has been built into its own folder, and then the main that we're going to call is built here, and it's just a bunch of JavaScript. So you can actually console log stuff in there if you're like quizzed about an error message and whatnot. Okay, so it's npm start, and that's going to use parcel. So one of the nice things also that the PureScript ecosystem has been converging with is using the parcel bundler. I used Browserify before, but parcel is quite nice because it has hot reloading, and so you have like the nice things from the JavaScript ecosystem. And so it's built, and we should be, yeah, it's supposed to be there. So let's paste this here. Okay, and we have some time, which is consistent with what we're expecting. So you see, it's already running in the browser, right? I git cloned, I npm installed, I spago built, but I didn't even need to spago build because I should have done npm start, because this spago built, which spago installs automatically and then runs parcel. So in 3 commands, you can get your program running in the browser. So I think the fact that this is so simple and that it uses also really good solid tools, yeah, that's a huge improvement, because sometimes just getting Haskell up and running is a pain. Okay, and so here you see if I want to modify this. So this is probably not, let's check the package JSON. It's probably not running an incremental build, but it's super easy to run an incremental build based on this. I can go into workshop, PureScript grain, and if I run spago build -w, which is for watch, then it will actually watch my PureScript source files, and then parcel will detect that the main.js has changed, and it will automatically update. So you get hot reloading directly from PureScript. So now I can showcase this by saying from, like, for instance, I can create another htext with hello, save this, that should rebuild. Waiting for the next file change. Right. I'm not in the examples. Made the same mistake again. Let's rebuild my DW. There we go. So it rebuilds. It gives us hello, and I save, and it hot reloads. So that stuff is super nice. Yes, it does have a language server. It integrates very well. Check this out. Hold on. Why is this not working? Maybe because I'm not at the root. So let me open this at the root, And then look at the main again. Well, I'll restart the PuseScript. Restart the PuseScript ID. So, Haskell restart LSP server where you have PuseScript restart reconnect ID. You see that there's some stuff in there. Let's see. Doesn't find it. I think the multi-root project is confusing it. So let me open it into a new VS Code window. And that's the commit thing. There we go. Now datetime, effect datetime. So hello +1. Oh wow, this works. Okay, markup was not found. Not working as well as I thought. Normally it works very well. Let's go build. Let's watch. Okay, I'll restart. All right, there we go. No type class instance was found. Okay. There is an instance for Monoid though. And yeah, it works and yeah, and it highlights. So it's pretty good. That's right, exactly. Yeah, it's not too bad, right? Like syntax highlighting and yeah, type documentation, inline documentation for stuff. By the way, the inline documentation for stuff, I was going to be unfair. It's pretty good. It's yeah, I was going to say it's better than Haskell. I think that's not exactly true. But yeah. Yeah, it's strange that it's not working. I thought that this would work, but yeah. It creates this PSC ID stuff, but doesn't work for a multi folder workspace apparently. Okay, so let's now check out what's up. So first of all, oh yeah, it is it's updating, but it's not. Oh no, it is updating every 5 seconds. Oh yeah, I didn't even notice. Okay, so how does that work? It does a listen thing. The updater has an update now, and then it has a listen now. It uses the JavaScript set interval. Okay. And then it gets the now each turn, which is fine because usually that's how you want to wire stuff. You want to wire with your lower level event sources. So yeah, I'm happy with that. And then what's the fine print here? So the view that's mounted is view, and then view itself has now view inside it, and now view is a component like the parent, and it uses the value for now, which is gotten from gproxy, and it just puts that into this htext. But all of this is wrapped in the external view, such that there's a did create function that's used with the listen now timer. So what is this did create thing? That's from the green markup. Okay, let's go take a look. Is there a nice doc in there? Usage and did create trigger when created a node. You can bind lifecycle handlers to an element. Okay. So when the handler gets created, then it calls listen now, which is nice. So it means that, yeah, it's lifecycle handler, meaning on component creation, it will install the hook. Perfect. And the hook will use the update now updater to regularly update the thing. Oh yeah, that's nice. I like this a lot. This is very clean way to do